everyone. It's Wednesday, April 29th, 2020, and we are working on Envisions 12-4 today. And the objective for this lesson is adding fractions with denominators of 10 and 100. So yesterday we did this as well. We worked with a little bit smaller numbers yesterday, and so we're going to step it up a notch and do a little bit harder. But before we get on to the lesson, I wanted just to do a little spiral review of just adding fractions, just our general adding fractions rule. Now, you can only ever add fractions if they have the same denominator, which means the bottom number always has to be the same. It's, you want to be able to make sure the pieces that you're talking about are all the same size. So imagine you have a chocolate bar. Your chocolate bar is broken into 100 pieces, and my chocolate bar, same size, is broken into 10 pieces. So whose pieces are bigger? Mine would be bigger, right? Because I only have one chocolate bar and I broke it into 10 pieces. I only have 10 pieces. You have 100, so yours are teeny tiny. So if we took my pieces and your pieces and we add them together, could we just count them like, oh, I have 3 and you have 12, we have 15 pieces? No, we really couldn't do that because your pieces are so much smaller than my pieces. So in order to be able to add fractions, we need to have the same denominator. Now in our examples, our spiral review, I do have the same denominator. All right, so we have 4 12ths plus 2 12ths. So as a reminder, we're going to add the numerator and we're going to just leave the denominator the same. So with using that rule, we're going to do 4 plus 2 equals 6. And 12, we're not adding that, right? We're just leaving that the same. 6 12ths. Now, 6 12ths sounds familiar to me. I think I can reduce this. Remember reducing? Reduce means to make smaller. What two operations make things smaller? If you said subtraction and division, you would be correct. Now in this case, we want to make an equivalent fraction that's smaller. To make equivalent fractions, we either multiply or we divide. So in this case, we would divide. Whenever we're trying to reduce a fraction, remember, we always try the top number first, right? Always try the top number first. If the top number doesn't work, try 2. And if that doesn't work, try 3, and then just keep going up from there. But chances are one of those will work. All right, so we're going to try the top number. 6 divided by 6 equals 1. And remember, whatever you do to the top, you have to do to the bottom. So if I divide by 6 on the top, I'm going to divide by 6 on the bottom. 12 divided by 6 is 2. So we actually can reduce 6 12ths to 1/2. Now I chose those numbers purposely so we could practice a little reducing, or simplifying is another way of saying that. All right, next example, regular adding fractions. We have 6 15ths plus 4 15ths. We're going to add the top numbers. 6 plus 4 is 10. And we're going to leave the bottom number, leave the denominator the same, so that's 15. Now I'm looking at my 10 15ths. And I think, well, I know I can't divide by 10 because 15 divided by 10 you can't do. But what's a bigger number that goes into 10 and 15? If you said 5, you were correct. So we're going to divide by 5. Remember, whatever you do the top, you have to do the bottom. 10 divided by 5 is 2. 15 divided by 5 is 3. So we can reduce that to 2/3. It's called reducing or simplifying. All right, so that's our review of adding fractions. And see how today I threw in reducing and simplifying as I review. It's always good to kind of review other math skills because learning math is like building not even a house, a big skyscraper. And you can't forget about the bottom things. So you got to keep going back to what you learned. Keep reviewing. All right, so let's get on to our lesson for today. And here's our example. We want to add fractions with denominators of 10 and 100. Now, I know I can't do that. I can't do 5 tenths plus 37 hundredths because the tenths is different than hundredths. This is a much larger piece than this. So I have to get them to be the same. Now I want my 10 to turn into 100. I want it to be 100. So what do I have to do to this 10 to get 100? So 10, now remember, to come up with an equivalent fraction, you're either multiplying or you're dividing. And in this case, I want to go from 10 to 100. So would I multiply or divide? Multiply. So 10 times what? 10 times what equals 100? 10 times 10. All right, and then whatever I do to the bottom, I have to do to the top, and vice versa. 5 times 10 equals 50. So now my new math problem is 50 over 100 plus 37 over 100. 50 plus 37 is 87 over 100. And there's my example. I have some more examples on the next board to review. All right, first problem, 17 hundredths plus 2 tenths. Now I'm going to leave my hundredths. Well, let me change my marker so you can see it better. I'm going to leave my hundredths and I'm going to change my tenths to be 100th, right? And the reason we're always changing from the 10 to 100 is because in order to get this to the 10, we can do that. You would have to divide. 100 divided by 10 equals 10. That's perfect. Except, remember, whatever you do to the bottom, you have to do to the top. So can you do 17 divided by 10? No, that doesn't work. So that's why it's always easier to start with the tenths and go up to the 100. So 2 tenths. I want to multiply this by 10. Ooh, that looks like a 16. I don't know why I always sit on this side because I'm a righty, so it's a little awkward. I actually have more hair on that side though, you wouldn't see me. Okay, 2 times 10 is 20. 10 times 10 is 100. So now we'd have 17 over 100. All right, sorry about that. Hopefully I'll be able to splice the two films together. So we have 37 100ths. Let's go into this example. I have 3 fractions this time. 3 tenths plus 4 tenths plus 11 hundredths. So I need to get these two to be the same as this. So I'm going to multiply by 10. So whatever you do to the top, you're going to do to the bottom. 3 tenths. 3 times 10 is 30. 10 times 10 is 100. Same here. 10 over 10. 4 times 10 is 40. 10 times 10 is 100. And then we're going to leave the 11 hundredths the same. 30 plus 40 is 70. Plus 11 is 81 hundredths. All right, down here we have 2 tenths plus 2 tenths plus 52 hundredths. So we need to get those tenths to be hundredths. So we're going to multiply by 10. Two times 10 is 20. We're going to multiply 10 here. 2 times 10 is 20. 10 times 10 is 100. And we're going to leave the 52 hundredths alone. 20 plus 20 is 40. 40 plus 52 is 92 hundredths. And here we have 3 fractions again. 3 tenths plus 20 hundredths plus 10 hundredths. Look, we have 100, we have 100. We're going to leave those. We want to make our 10 the same as that. So we're going to multiply by 10 on top, 10 on bottom. 3 times 10 is 30. 10 times 10 is 100. Plus 20 hundredths plus 10 hundredths. 30 plus 20 equals 50. Plus 10 is 60 hundredths. Oh, we can divide. We can simplify this one. So these are both even numbers. We know 2 goes into that, right? But if you divide by a small number, you're still going to be left with pretty big numbers. So what number can we divide, a big number, into both of these? And I think, well, if 2 goes into both of those, and it's 60 and 100, I bet you 20 would go into it. So let's try to divide by 20. $60 divided by 20, so 20, 40, 60, 3. 100 divided by 20, 20, 40, 60, 80, 100, so 5. So we broke it down from 60 100ths to 3/5. Alrighty, well, keep your fingers crossed that I can put those 2 videos together. And we are going to see you in small groups today in math, so I'm excited. If you have any questions, we're going to review this in our small group. Please ask me, alrighty? So I'll see you guys in a little bit. Bye!